We all know that we shouldn't really add too much code inside our methods. We should keep our methods clean. I recommend that we refactor our code just a little bit. At the same time, also learn about introducing our own asynchronous methods. You're now going to take all the code from the method searchClick and move that into a new one. Then we'll call this method from the searchClick event handler. The first thing is to introduce the new method. Let's call it getStocks. This is going to be an asynchronous method that will be awaited inside searchClick. Nowadays, it's less common to suffix methods with the async word, because a lot of editors will hint you that you need to await the task that is returned. Therefore, we'll keep the name simple. For the implementation, we have two options. Either getStocks returns the data that it's loading from the API or disk. Alternatively, as with the code we copied from searchClick, we could interact with the UI from this method as well. If we choose to do all the work inside getStocks, we could just paste the code from searchClick. Before we do that, let's talk about a few things first. To introduce an asynchronous method, we know that we first introduce the async keyword. Marking a method as async simply indicates that this method will have the capability of executing and awaiting asynchronous operations. Remember, if we don't have the await keyword, we do not need the async keyword either. Currently, the method signature indicates that this method doesn't return anything. It's a simple void method. Adding the async keyword means that this is now async void. Whenever you see this, you should really be worried. Async void is evil and is something that you should always avoid if you can. How come you're allowed to do async void if it's such an evil combination? The reason is event handlers. If you want to have asynchronous code in your event handlers, the delegate for an event handler is most certainly returning void. Therefore, the only time you are allowed to do async void is for event handlers. Keep that in mind because it's really important. The method getStocks is a normal method and not an event handler. How would you indicate that this is an asynchronous method that doesn't return anything without using async void? Instead of having the async void method signature, you can use async task. Changing the method signature to async task didn't require any change to the method body, and it didn't produce any compilation errors. In fact, adding the async keyword will make sure that a task is automatically returned. The compiler will do this for us. The task will be a reference to the ongoing asynchronous operation, which you could await wherever this method is called. We'll talk more about the task and its many useful methods in the next module. Then later in the course, we'll talk about what the compiler generates, which might seem a little bit like magic. With the method signature set to async task, this now allows you to populate this method with asynchronous operations. The caller of this method will have a reference to the ongoing operations and can await that to make sure that it completed successfully. Let's add the code from searchClick. This will load the stock data. It'll ensure that there were no exceptions and finally populate the data grid. If a problem occurs, we'll get a note in the notes section of the application. What's important here is that the only asynchronous portion of this code is the retrieval of data. The code that updates the UI is not going to be executed asynchronously. This means that if we were to perform a heavy operation before or after the await keyword, this isn't something that's offloaded to a separate thread. The code after the await keyword will be executed in the continuation, which would be the UI thread. You've introduced your first asynchronous method. To whoever calls this method, they will see that it returns a task and know that it performs something asynchronously. While at this point we only consume existing libraries to introduce an asynchronous call, you will later learn how to perform heavy work on a separate thread together with the async and await keywords. When we introduced this method, we made sure to follow the best practices of not returning void from a method that's using the async keyword. You could not call this method from search click. The event handler still needs to be marked with the async keyword. That's because getStocks is an asynchronous operation which we'd like to await. The method returns a task, and we need to make sure that this operation completed successfully. Therefore, you introduce the await keyword. The code was refactored, we've cleaned it up a little bit, and made sure that we have minimum amount of code inside the async void method. Run this, and you will see that it still works. We can search for stocks. It'll populate the data grid, and if you search for a stock that doesn't exist, a note will be added to the application to tell you there was a problem. I would say that it was super easy for us to refactor the code into a new asynchronous method. I mentioned earlier that the compiler takes care of returning the reference to the ongoing operation for a method marked with the async keyword. And earlier we talked about that the await keyword is something that helps us get the result out of an operation, and it's there to help us validate that the operation completed successfully. While getStock doesn't return anything itself, the returned task is generated and added by the compiler. This needs to be awaited in whoever calls this method. Making sure that this is awaited is sometimes referred to using async all the way up. At the top level, in this case, the click event handler, is where we want to await this asynchronous operation. If there's a problem inside the asynchronous operation, we need to make sure that it's validated and that potential exceptions aren't lost somewhere along the way. If you set a breakpoint at the top of search click and trigger the event, we can step through the code and see how it behaves. This will execute on the UI thread. When stepping into getStocks, this code is still being executed on the UI thread. As we reach the call to start an asynchronous operation to load some data, a separate thread is being created where it loads all the data. When you reach the await keyword, all the code beneath it will be executed in the continuation only once the data is available. Therefore, you can see that you're passed back to the method searchClick, and the code until the next await keyword will be executed. Once that is reached, a new continuation is introduced. Finally, when all the data is available, the first code that is executed is the rest of the code in getStocks, followed by the rest of the code in searchClick, after the await keywords. This shows that it's super simple for you to introduce your own asynchronous method. We refactor this to make the code a little bit more readable. Remember that we could apply the same approach inside ASP.NET, a console application, MAUI, or really any type of C# application.